Hello and welcome to episode 17. So you might be wondering, how do we access the items in the set if they don't have an index? So we will just make our set really quick. Fix that. Okay, we've got our 3-item set. Pretty standard for us at this point. And then we are going to use a for loop just to print each of those for now. So we will print I in X by doing so for I in X, and then remember the colon, we will just print I, new terminal. We're up to 17 now, and then you see that we get the response that we were hoping for, which is the value for each item inside of the set. Now, sets don't have indexes. I just use I out of habit. You certainly do not need to use I. As you know, you can name this anything. You call it nums, since these are strings of num names. Whatever you want to do. The other thing you can do that we know works, this is just a kind of a refresher from everything else that we've covered, but you can check to see if a value is in a set. So print 2 in X, save, and we get a Boolean value back. So just remember that. You can check to see if values are in here. You could even loop through. So you could do like this, and we'll just copy that. And then we'll just do for I in X, and then we will actually just print this, and we will search for I. And we'll see if I is in X. Obviously, you're going to get trues because, and just so you know, it printed 4 trues because it's still doing this print. You're going to get 4 trues or all true because it's actually pulling the value from the set. So it better be in the set. But just so you know, you can mix and match different things and mess around with it in for loops and everything to see how it works. Now remember, we said that you can't, that sets have to be unique, and you can't change the values inside of a set, but you can add to a set. So we'll cover how you add really quick. So you would just take our set name, which is X, our variable here, dot add, and add is a function or a method, and then we will just add 4. We will print X after adding 4, and order of everything matters, and we can kind of show you that really quick. So now you see that it added 4, and remember they are not ordered, so we can get different output. But 4 is in there. Our value did get added to the set. And just to show you that the order matters here, we'll just copy this, or cut it, and paste, save, print, and you see that we only have the 3 values because we're calling the print method or function before adding 4. So if we print X again, let's see. So if I haven't covered that already, just know that order is very, very important, especially with like when you're scoping everything and writing a full app. You want to make sure that everything's executing in order. All right, I'm going to just cut this out, speaking of order, and put it down here. And you can see that we're getting an error. That's also because of order here. I'll just delete that, and we'll just comment out these 2 little blocks. Save, and move on. So the other thing you can do with sets is you can add elements from one set to another set. So we have our set here of X, and then we have Y. Remember that we can use integers and stuff in sets. So then you can do X dot update, and in update we will pass in Y, the set of Y, and then we will print X, save, and you see that it added those 3 items. And again, out of order, right? Not ordered. So just always remember that when you're dealing with sets. If you're trying to get a specific output in a specific order, it can be very troublesome, and maybe you should use something else. Okay, the important thing to know too is that you can do this update with any iterable. So we can change this to a list by using those square brackets, and update's still going to work. So you see when we run it, and the interesting thing is that it put all 3 numbers together, but I'm glad that it did it out of order, because it's important to know that even though a list is ordered, once you're updating it into a set, you're not getting an ordered response. So if we run it a few times, you can see that the 1, 2, 3 get broken up, they get moved in the set. A lot of times it appears that they're up front, but it's not reliable. So something to keep in mind. Okay, and then you can also remove things from a set. So we'll just copy this set up here, print it down here, and then we can remove using the remove function or method, and then you want to pass in what you want to remove. So as usual, we'll get rid of 2 because we don't like it, and then we will print X to make sure that 2 is out of there. And it is. We've succeeded in removing 2. If the removing item, if you pass something that doesn't exist, like if we pass 4 in here, we'll get an error. So something to keep in mind. And this is a pretty straightforward error. It's looking for the key of 4. There is no key of 4, and so it can't remove it. So very straightforward error. I'll change it back to 2 in case you're taking notes, so that it does work for you. You can also use discard method. So we can do, and we'll just comment this one out. Save, run, and you can see that it's also discarding it. You might be wondering, why would I use discard instead of remove? Well, discard doesn't raise an error, so it won't crash an application. So if you don't know what data is going to come into a set, but you do know that you want specific data removed from that set and you are going to get rid of it, you would use discard so that you're getting rid of that, and that if it doesn't actually get pushed into that set prior to you searching for it to discard it, you're not going to get an error and crash your application. Another method or function that works is pop. So we can do this, and you'll see there. And then also we can assign it to a variable. So we could say that y equals this. Save, we can print y, and we can print x, save and run. And you see that the value that it popped out of the set, it applied as the value to the variable y. So it popped 1 out, the string of 1. It gave the variable y the value of 1. So when we print it, we see 1. And then the remaining set, after popping this out, is 2 and 3. The string's 2 and 3. So we get that return value. This is another data structure and algorithm thing you'll use a lot, and you might be using it for other use cases as well. The one warning I will give is, because lists are sets are unordered, just remember that when you use pop, you might not be controlling what you're popping. Okay, another method that we can use on sets is clear. So we'll copy paste this down here. We'll do x.clear, and we should not be seeing anything. We'll run it. So you just see a set, an empty set. So then if we comment this out, another thing that we can use again is delete. So del space x, save, and you see that it's not even defined. So instead of getting an empty set, we're actually getting that x is deleted, so it's not defined at all. So you would actually have to reassign x here to something like 0 or whatever to get the output, because we deleted the entire variable from existence. And if that difference doesn't make sense to you, just comment and I can try to clarify it better. But basically, clear is just emptying the set, but it's not destroying the set. The set still exists, it's just empty. And delete is deleting the actual set itself. Now, like we've already seen, just to cover the loops, you can use the for loop, which we have already done. So we'll do for I in x, and we'll just print I, save, looping through, and again, it's unordered, so you're getting random values back. For joining two sets, which we've kind of covered a little bit already, we have the update and the union methods. So I'll just comment this out and move the X really quick. Copy that, paste it, and we will do another set. Very creative. And so we have set 1, set 2 here of X and Y, and then we can set Z to X dot union of Y, and then we can just print Z, save, print, and you see that it unioned both of them. And again, just because I got lucky where this printed in order at the beginning, these integers, don't rely on it because it's a set, so it's not in order. So we're just getting, like, this one was very lucky. So other than union, you also have update, which will insert the items in set 2 into set 1, and from like Y into X here. Union's actually returning a new set, so that's a little bit different. Like, this one's modifying, union's returning a new set, and update is modifying the existing set. So you would just do X update here with Y. You don't assign it to a new variable. You could, but you don't have to assign it to a new variable. And you see same basic output, but it's just important to know that one is modifying the original variable and union is assigning them to a new variable in a whole new set. So these sets are not changed. It's just combining them into Z here with union. And if you have a set that has a same value here, both update and union will get rid of that. So you see there we only have one string of 3, one string of 3. No matter how many times we run it, one string of 3. And if we change this to union, or if we just do, we'll comment this out and then uncomment that. Save. Same thing. So sets are unique anyway, so it's just a function of the set, but just know that both of those will remove duplicates if that's something that you're worried about. If you're merging, say, like 2 giant files, 2 CSV files or JSON files or something, and you have everything pushed into sets for whatever reason, like an ID or whatever, and then you're merging all that stuff, just know that sets are really good for removing duplicates. Okay, so this is kind of an interesting method. So we have these. I'm going to add a couple more duplicates in here. We'll just actually do the number 4 and 4, and then comment this out and that for now. And then, so this one is the intersection update method or function. So we'll have x dot intersection update, and it's underscore update. And then you pass an argument in, which will be your other set. Save that, print, and we want to print the original that we're calling the method on. So we're not calling Y here, we're calling X. We run it, and so what intersection update does is it actually only keeps the items that exist in both sets. So it only keeps items that exist in both set X and set Y. And then it changes it so that X is the set that has both of those. Another thing that you can do is just intersection, and I'll just comment this out because I don't want to remove it for notes purposes. So you can do something like Z, we'll assign it to a new variable, intersection of Y, and then we want to print Z, save, print, and now we're getting a new set, Z, which has all of the intersection values. And that's probably more common for what I've experienced and what I've used it for. I would usually, anytime I'm doing something like this, I'll just save it to another variable so that you have your originals kind of sanitized and untouched if needed. Okay, so now we have a kind of an interestingly named function, which is symmetric underscore difference underscore update, and we'll pass in Y. And then this is the opposite of what we saw before with the intersection update. This is looking for the symmetric difference update. And we will print X, and you'll see the output here. It's just giving us the ones that are unique from both sets. And then just really quickly, you might be thinking, well, if we're just removing duplicates, isn't that the same as union or update? And it is not, even though you might think that. So if we do union y here, x dot union y, and we print it, this one is completely removing anything that's duplicate. Union will keep one of the duplicate values. So when you run it, you can see the difference here. So it's keeping one of the 4s, one of the 3s. Symmetric difference update isn't keeping either of those. So it's only keeping whatever appears once in the sets that you're having it analyze. Now another method, just like the intersection update and how we have intersection, we have symmetric difference update, and we also have symmetric difference. So we can take a variable like z, and we can type symmetric difference underscore difference, pass in y, and then we want to print z down here, save, run, and you see that we have 1, 2, 2, and 1. And so the same output, we're just assigning it to a variable here. That's the only difference. And you might be wondering, well, do we have to assign it to a variable? Well, if we change it, if we just delete z here and we change this to print x, we save and we run it, you see that we get a different output. So we're getting 1, 3, 4, and 2, which is a different output. So if we're doing so here we get the 1, the 2, the string 2, and the string 1. And up here we're getting the string 1, the string 3, the string 2, and the integer 4. So we're getting different outputs there. And if you notice, the output, if we remove assigning it to a variable, we're just returning the set. So we have 1, 3, 4, and 2, 1, 2, 3, and 4 right here. Alright, we're almost to the end of sets. We just have a brief overview of their methods. And I know the video is getting long, but just hang in there. It's just the methods and then we'll be done. Alright, so I've added all of the sets here that we have, methods for sets. So we have the add, which adds an element to the set. You've seen that one. Clear, which removes all elements from the set. We went over that one. Copy, which just returns a copy of the set. Difference, which returns a set containing the difference between 2 or more sets. So just the different values that are in the set. Difference update we just went over, which removes items in the set that are also included in another specific set or specified set. Discard, which removes the specified item. We went over that one. And remember the difference between that and remove. Intersection, which returns a set that is the intersection of the 2 other sets. So all of the things that are duplicates. Intersection update removes the items in the set that are not present in the other specified sets. So it's removing, if you see this one returns a set that is everything that's duplicated, this one removes everything that is not duplicated. So that's the difference between them. And remember, you have to pass in the second set in here for it to take both of them into account, and you have to assign it to a new variable with the one method with intersection. Is disjoint returns whether 2 sets have an intersection or not, so that will be a Boolean value of true false. Is subset returns whether another set contains this set or not, so if all of the values are in a set or not. And feel free to mess around with all of these. Is superset return whether the set contains another set or not. Pop, we went over, it removes an element from the set, and it's kind of chaos since they're unordered. Remove removes a specified element. Symmetric difference we just went over, returns a set with the symmetric difference of the 2 sets. Symmetric difference update inserts the symmetric differences from this set and another. Union returns a set containing the union of sets, and update, which updates the set with the union of this set and others. So thank you for tuning in. That covers sets. If you want to head over to w3schools.com and type in set exercises, there are exercises there to practice all that you have learned, and we have covered all of it, so you'll you'll do well.